significant figures. Significant figures. It is the most important topic regarding entry test point of view. ETEA, NUST always ask about it. So, number from 1 to 9 are significant figures. For example, 5, 2, 7, 8, 9 have 5 significant figures. 0 in between significant figure are significant figure. For example, we have 2003 or 2.0042 having four significant figures and having 1, 2, 3, 4, 5 significant figures. Similarly, 0 on the right side of a significant are not significants. 0 on the right side of significant figure are not significant figure. For example, we have 42000, so we have only 2 significant figures. 0 on the right side of a significant figures are not significant, but when the number is written with unit or decimal point, it is significant. The 0 on the right side are not significant figure, but if the number is written with decimal or unit, it becomes significant if it is written with decimal or unit. So if we write 42.000, in this example we have 5 significant figure, or if I write 42000 millimeter, so here we have 5 significant figures because I have put a point, a decimal point before the zeros and put a unit after the number, so it becomes significant. Then next we have 0 on the left of the significant or not significance. The zeros on the left of significant figure are not significant figure. For example, if we have 0.0023, we have only 2 significant figures. So in scientific notation, digits other than power of 10 are significant. In scientific notation, digits other than power of 10 are significant. For example, if we have 2.310 raised to power 5, we have only 2 significant figure. In measurement, all the accurately known digits and the first doubtful digits are named as significant figure. In any measurement, all the accurately known digits and the first doubtful digits are named as significant figures. It will be more clear with this point, and it is the most important point regarding NUST entry test point of view. They usually ask about it. For example, we have a meter rod reading 1 reading is 12.438 and having least count of 0.1 millimeter. So how many significant figures are present in the reading? The meter rod having a reading of 12.438 millimeter and having a least count of 0.1 millimeter, how many significant figures are present in the reading? So we know that the reading is 12.438, but the question arises, how many significant figures are present in the reading? As we have only one digit after the decimal, similarly we mark the one digit after the decimal, and we have three significant figures in the reading. Similarly, Vernier Calliper measures a reading of 2.772 centimeter and having a least count of 0.01 centimeter. So how many significant figures are present in a reading? As we know that the reading is 2.772 and least count is 0.01. We can see that we have two digits after the decimal, so we take two digits after the decimal and dropped the other one. So the total significant figure in a reading is 1, 2, 3. Three significant figures. So here is a hint that smaller the least count, greater will be significant figure. Smaller the least count, greater will be the significant figure. And sometimes ETEA and NUST entrance examination ask about that. If you have 4.2 plus 1.778 plus 7.22, so how many significant figures in the result? And having an options of 13.198 or 13.1 or 13.19 or 13. So here is a trick that the significant figures in result will be equal to the fewest digits to the right of the decimal point. Trick is significant figure in result is equal to the fewest digits to the right of the decimal point. In this case, we have one digit after the decimal. In this, we have three digits after the decimal, and in this case, we have two digits after the decimal. So fewest digits to the right of the decimal point. In this case, 1 is a right one. So in result, we have only one digit after the decimal. So B1 is correct. 1.72 multiplied by 4.222 divided by 15.777 is equal to the results, the significant figure in the result, and having a choices of 1.2570, 1.25 or 1.2 or 1.257. In the solution of this question, you will repeat the same trick as we have mentioned before. We have 2 digits after the decimal as the fewest digits to the right of the decimal point. So select 1.25 as a result and having 3 significant figures. Through this trick, you can solve 5-minute question in less than 5 seconds. So rounding of data. Rounding of data. Rule number 1. If the digit to be dropped is greater than 5, then add 1 to the last digit to be retained and drop all the digits further to the right. If the digit to be dropped is greater than 5, then add 1 to the last digit. To be retained and drop all the further digits to the right. For example, if we have 8.677, here we see that 7 is greater than 5 and the last digit is 7, so add 1 to the last digit. So it can be rounded off as 8.68. If we need only 2 significant figures, so it can be further rounded off as 8.7, because 8 is greater than 5 and plus 1 to the last digit. So 6 plus 1 is equal to 7. Rule number 2. Rule 2. If the digit to be dropped is less than 5, then simply drop it without adding any number to last digit. If the digit to be dropped is less than 5, then simply drop it without adding any number to the last digit. For example, if we have 8.632, if we need only 3 significant figures, then it can be rounded off as 8.63. As 2 is less than 5, so simply drop it without anything to the last number. It can be further rounded off as 8.6 because 3 is again less than 5, so simply drop it without adding any number to the last digit. Rule number 3. Rule number 3 is that if the digit to be dropped is exactly 5, if the digit to be dropped is exactly 5, here we have 2 possibilities. Possibility number 1. If the digit to be retained is even, then just drop the 5. If the digit to be retained is even, digit to be retained is even, then just drop 5. For example, if we have 6.65, and we need only two significant figures. Then the digit to be retained is even, as 6 is an even number. Then just drop 5, so it can be rounded off as 6.6. Possibility number 2. If the digit to be retained is odd, then add 1 to it. If the digit to be retained is odd, then add 1 to it. For example, if we have 6.35 and we need only two significant figures, so here the digit to be retained is 3. 3 is an odd number, so it can be rounded off as 6.4. One thing to be remembered: remember one thing, that 0 is an even number. 0 is an even number. For example, if we have 4.05, so as 0 is an even number, it can be rounded off as 4.0. Just drop 5 and get the two significant figures.